And we are live. Sorry, Joe and I are cracking up here. Funny inside joke. Anyway, good morning, afternoon, evening. If you're watching this live or watching it recorded. This is typically the Joe show. Oh, wait, Joe's show. But
right.
felt he would be lonesome today by himself, so I figured I'd join. I'm Tom, run our customer success team here at Ascend. And I know nothing technically about security. I just know it's very important. And I will say, before I just totally turn this over to Joe, the great thing about folks like Joe, where in my world that I live in, right, you at two ends of the spectrum, you've got security people and teams that, because of the way they try to solve the security problem, intentionally and unintentionally, are constantly getting in the way or in your way. Really hampering productivity. And then you got folks like Joe who are solving still the same problem in the right way, but they're thinking about how to solve it at its core and in a way that enables people like me, right, to do my job and not always have to call the security people. Why can't I do this? Or why can't I get access to this? Or why can't I have that? So with that said, this is probably my sole contribution today, other than maybe a clarification comment or two, and I'll flip it over to Joe.
Gotta get you to introduce me in more things. Let's go well. All right. So as Tom said, we're talking about security today, specifically about enterprise data security. So we have been a secure data product for at least as long as I've been here. I don't know what happened before, but you know, we do think security is generally important. And I'm going to start with a bit of a philosophy question here. Were these walls built to keep something out or something in? The answer is both. And you'll find out why in a minute. So this is the Infra Tuesday stream. We talk on some number of Tuesdays. It's not 12:30 today, but you know, whatever. Scheduling's hard. What are we going to learn today? Let's dive in a little bit. This is one of our longer topics, so it will be a two-parter. But today specifically, we're going to talk about what you actually secure in a data product. This is going to be the really big differentiator about enterprise data security relative to general security. We're going to get into how you actually go about securing whatever you do secure in a data product. And then more specifically, how do you secure a data product from its operators? You know, you have intruders, you have operators. How do you start to treat them as sort of both threats? In the second part, presumably next week or whatever, how do you actually implement each layer of security? We're going to get into the nitty-gritty of what are the differences in places where you might be running, and how does that impact how you actually can implement these portions of security for whatever you're working on. And then what are the things that we ran into that we can give you some eyes on so that as you're working on your next project, you don't need to make the same expensive mistakes. So jump right in. What are you actually securing in a data product? Data. It's really that simple. So as you talk about the you know, your customers who are coming to you with a data product, they are coming to you because that data is valuable. Whether they think that they can gain insights out of that data, or potentially whether that data that they have, they consider to be their actual IP and market advantage. We see this in many cases with financial companies where the data that they have, those are market secrets, and they want to leverage those specifically in order to make more money. So the security of that data is paramount to them getting any value from you, because if you do not protect it, they have lost that advantage. But on the other side of things, data is in many cases, I would actually argue most cases, inherently sensitive. If you're storing data, that data is typically about something or someone. In a lot of cases, it is PHI or PII. We do some work with companies around healthcare, and that is implicitly sensitive data. It is protected. People have privacy, and that is important to maintain. But in other cases, we actually have customers who have gotten data from customers that they're working with, and they are entrusting us with the security of that data, with processing it, with doing something with it. In many cases, actually powering their business intelligence. So they already have this level of trust they have given to their customers, and we need to recursively honor that. We cannot breach that contract 2 levels down. So with that backdrop, how do you actually secure a data product? It's actually fairly simple. When you frame it this way, because it's not some squishy security around like, well, are we kind of trying to protect systems, or we're protecting access, or we're protecting, whatever. You're protecting the data. And if you work your way out from that, you can simplify a lot of the questions that you need to answer architecturally. So that it is, again, very simple. If customer data is compromised, it's game over for us. If people cannot trust us to process their data securely, if they cannot trust us to handle data, then we are out of business. So that is ground zero. So the way you start this obviously is external. At the beginning, you start with protecting the data from people who are not inside the company. And you all pretty much know how to do this. Authentication at every endpoint. No one should be able to walk in and just start grabbing things. Maintain up to date with security updates. When there are patches, when there are CVEs, pull them in, update your software. This is basic operations. End-to-end encryption is something that we ended up building out, almost 2 years ago now. It's valuable to have because you have this better control over the life cycle of data itself and when it can be viewed and by whom, because you are managing those keys, because you are managing the actual guarantees of that data being encrypted, and you know when it is unencrypted, and you know in order to be used in memory, wherever that may be. So you can simplify the scope of attacks there. The next big thing is actually app level security. So this is pretty, again, we kind of consider it table stakes. If you look at things that enterprise customers will ask for in products, one of the top things that's always a tick over for whether or not something will get purchased is basic RBAC. Can you segment up access by the users in a company such that you can have some users who, maybe they are an analytics team and they just need access to the pure cleaned up data sources, but you have a data engineering team or an SRE team who needs to have broad access so they can orchestrate getting data from many places, and do all of that cleaning before it gets to the consumers of that data. So it's important at the application level to be able to do that. So like I said, RBAC. Doing this really well is very difficult. I've seen a lot of RBAC systems and identity and access management systems, and a lot of them are really not great, but they generally offer the basic components that you need to do what you do, and it's that base level that you do need to provide. I think shining pinnacle of capabilities in RBAC is Amazon Web Services IAM. It is infinitely composable. It is the most powerful RBAC system I've seen anywhere, but it is also very difficult to learn and very difficult to, well, can be difficult to get right. And people complain in many cases because it is so powerful that it can be difficult to understand. So moving a little further though, so we've talked about you need to defend against external attackers, and on the actual customer side, you need to provide security within the scope of the customer themselves. But what about securing against dissent employees? Why would we do this? Real question, why would we do this? Why is it important? A couple weeks ago, Twitter got hacked. It was an incredibly huge, highly public attack on the most public figures on Twitter. It was massive. It is shattering for any trust in Twitter security. It has to hurt their bottom line at some point. And why did this actually happen? Why was it possible? There were a number of failures that they left themselves open with. First big one, they had a compromised employee. So they are a much larger company. They had someone who actually reached out to a hacker and said, "Hey, look, I can do all these crazy things. Let's do some hacks." That is a very extreme case, but it is a thing that can happen. That shouldn't have been an issue though, because it shouldn't have been possible for some employee that they just hired to have enough permissions to do everything that they did. The big scary thing that they ran into next, they had very powerful creds that were just shared in Slack. They were pinned in a Slack channel. This meant anyone in Slack, I mean, it's anyone who has worked with security professionals with a Slack organization has at some point probably gotten yelled at or seen someone get yelled at for posting credentials in Slack. There's a reason for this. It is very difficult to actually manage access for credentials in Slack because it's not a cred manager. It's meant to be a source of record for conversations and for organized communications and making things easy to find within a company. It's not meant to provide granular access that can potentially be rescinded for certain string values that are stored in it. So this was actually particularly bad. They had the creds pinned on a public channel. That's about the worst thing you can do. That's just basically putting a key on top of the doormat in front of your house. It's not good. In addition to that, there was this effectively God mode tool in Twitter where that was granted pretty broad access to employees, and with that tool, employees could do almost anything to any user in Twitter, whether it was taking of their account, posting on their behalf, seeing their DMs. Like there's it. Based on the output of this hack, it appears that there was effectively unlimited access, and the access to that tool was effectively unrestricted. Like I said, there was a cred, and there was actually a link, I believe, to this tool in that shared Slack channel. Again, it's really basic stuff, but because they did all these things, they left themselves open to what amounted to a very, very, very large public breach. The monetary gain for the hacker may not have been that high, but the loss for Twitter was substantial. So what can we actually get out of this? There's a lot of things that I think are worth talking about here. I very much hope to not have to worry about compromised employees who are offering up their services to external attackers to attack our company from the inside. I personally trust our employees, but that's actually not in conflict with restricting access. Employees don't need full admin access on everything that they work with in order to do their jobs. It's very basic, actually. It's the concept of least privilege, principle of least privilege. You should only have as much access as you need to do your job. And as Tom alluded to earlier, this is the job of security to institute this, but the job is specifically, while the job is to make things secure, the job is also to make things operable. And this is where there is a concert between security and operations tooling, because you can make things more secure and also easier to work with by building secure tools that automate processes and allow developers to interact with some trusted system that can work on their behalf.
Yeah, you beat me to the punch here. This is precisely where I was going to hop in, and just meant, countless times I've just been stymied, right, by the enterprise and the security teams on doing things that I should be able to do. So not to belabor this too long, but the more time you and people like you spend on this, making it work for the organization, the far more efficient and effective people like me can be. And also to your trust point, like I think all of us out in the user community, if you will, have to understand that statement around trust. I know Joe trusts me, but he should not trust me enough with the keys to the gates, the pearly gates. That would be very wrong to do. Not that I'm an evil person, but there's no reason, right?
Yeah, and even to that point, it's not even necessarily an issue of trust, because it's, even if Tom is trustworthy, like, he may be compromised, not even morally compromised, but literally compromised by another actor. So it's another potential point of failure in the security system, where if Tom has credentials, then we have to worry about Tom being a point of attack. If there are fewer and fewer people who have broad access, then you can really focus on locking those people down. Whether it's MFA, whether it's YubiKeys. Like, I've got, like, having physical authentication is important, so YubiKey. Like, I use this for my second factor because it's even more secure. It's just good practice. It's not an issue of personal trust.
Yes.
So how do you do this? So remember what we said before. Remember what you are protecting. You're protecting data. As you are building a startup, a lot of what you'll find in these very early systems is, if you can talk to the security, infrastructure, SRE person, whatever, in there, and be like, all right, how do we lock people out of the product? And they'll think about it for a second. And in their head, they've come up with 15 different ways easily to get access to everything, and to privilege escalate and whatever. And if you start trying to just check all those boxes of like, okay, how do we lock it down there and there and there and there? It's an immense task. It's very difficult to do. It's hard to leave this very broad attack surface open and lock it down. So let's not do that. Let's approach it a little bit smarter, and let's start by reducing the actual attack surface, reduce the number of paths to get to the thing that you're protecting, and because that thing is the data. So build these layers of gates of protection between the people who need to do stuff and the data. And then that it simplifies it. So layers of gates. Tell me about these layers. Caveat up front, some of this is a little bit specific to our tooling, but I will try to give the useful explanation that you can use in your own career. So let's go ahead and start from the top here. I've broken this down into access management layers, cloud portability, because again, we do everything with the backdrop of we are multi-cloud, we are on GCP, Amazon, and Azure. So if something does not work on multiple clouds, it is less valuable to us than something that does. I pulled in the impact a layer has on the tooling because that will affect design decisions that may be useful to you to make early on to make implementation of these gates easier. Just useful knowledge. And then like, what is the actual things that gets you through that gate? So starting through it, first thing, application level access. This was actually like, we had this built out already. We've had application level access for a long time because we knew we were going to sell to enterprise customers, and you have to have that. The thing that we had to start building in though was, all right, so what happens when application level access is not just applied to the users, but also is applied to the operators? What happens if we revoke all site admin access from Ascend employees? How do we do that? Are there assumptions that we're currently baking in that we have admin access, that we can do certain things because we have this access? How do we get around that? How do we still continue to operate? This starts to get into things like, how do you observe? How do you get access to your metrics tooling, your Grafana logs, whatever, what have you? How do you look at if a customer needs help with their, some data flow? How do you operate that? This is one of the more straightforward ones because we build the app to be cloud portable, so it is inherently cloud portable. This has nothing to do with the cloud underneath. It is application level logic. It has very low impact on the tooling. It does require you to redirect some of the tooling, so make sure that your metrics are available elsewhere. But like we've been using Sumo for logs for a long time now, so we already have logs elsewhere, like in their own secure log collection product. This one is fairly straightforward. If you're not authorized in an Ascend environment, you cannot get in. We are looking into more interesting granular solutions so that we can have more ability to support customers in their environment without seeing their data. So for example, creating different kinds of roles that can go into the product, see configuration, see error logs, but not preview rows of data from the actual customer. Because again, remember, the data is generally the most sensitive thing. There are customers for whom their configuration will be sensitive, for whom the business logic that they build in our application will be their IP. That will be something they consider to be their market advantage, and they will not necessarily want us to see that, and we'll have to work around that. But in a lot of cases, they're doing basic filtering, basic, reshaping, partitioning, something to just use us to get the data somewhere in a nice package. And in those cases, a lot of the time, they don't want us to see the data, but whatever, they're fine with us seeing them, changing a timestamp into a date time. Like, that's fine. don't care. Moving on a little further though, and this is where you start to get the really narrowed down layers. The data that we have for our customers resides in two places. It resides in buckets, whether that is S3, GCS, Azure Blob Store, or MySQL. The raw data is always in buckets. So the first way you can narrow this down is restrict access to the buckets, but specifically restrict it in such a way that only things that need access to those buckets can get to it. And those things are the customer environment itself. So the network where the product is operating, where you have these VMs sitting, make it so requests to those buckets must come from that network, whether it's VPC endpoint, whether it is the egress IP. I believe every cloud has VPC endpoints at this point. So you can do that. And then all of a sudden, you can't go into the console and just look at the bucket. You can't just use AWS S3 CP remote file download to my laptop. You cut off this whole swath of access points, and you've massively simplified the problem. So is the solution on this cloud portable? Not even remotely. It's actually 100% different across all three clouds. That's something we're going to dig into the next part. But it's really painful. And this is where the power of Amazon's IAM system actually becomes really interesting, because it makes it very easy. And it's actually quite hard in the other two clouds. This ends up having an impact on your tooling, though. And the first place that you'll actually see this is if you're using something like Terraform. If you have a firewall on from where your buckets can be accessed, that actually includes the access to creating those buckets. At least in Azure it does, because of how a storage account works. So you end up needing to have a static endpoint that you can run Terraform from. And because you're locking this down, it needs to be a locked down static endpoint you can run Terraform from. So you start to get these little layers of complexity. The way this simplifies it, though, is that you end up restricting it such that you must have access to the VMs in order to actually get access to this data, which is actually a much simpler problem, because we run everything as everything is Kubernetes. We don't SSH to our clusters. We just use the Kube API to interact with them. So if you can start to manage the Kubernetes access, so that you must have some level of authorization to get there, you can then start to solve the rest of this problem. So that's our next layer, is Kubernetes access. So Kube access, as it turns out, there's a number of different ways that you can potentially solve this. You can solve it at the cloud provider layer. That's not very portable. The solution we ended up going for was portable, we're using Teleport as an authenticated proxy, and that allowed us to narrow down the scope of work and have a single solution across all clouds. So it does also have an impact on your other tooling, because what else has to access the Kube API? Whatever you're using for deployments. In our case, CircleCI. CircleCI happens to not have a static endpoint. It's actually kind of a big pain point with them. So CircleCI needs to know how to proxy through this authenticated proxy, just like everything else. So that ends up causing some problems, but it is solvable. Teach Circle CI to go through the proxy and restrict firewall access on the kube API such that only this proxy is allowed to get to the cluster. What this all means, in order to get access, you have to be a member of an authorized OAuth group. So we have an OIDC, and if you are part of engineering, you have some role. If you're part of the admin set of users, you have a higher set of permissions. The last big one, and this is one of the trickier ones, is CI access. So again, we use Circle CI, and one of the things that you can do in Circle CI that's very convenient is you can SSH to jobs. But if you can SSH to jobs, you can see the creds that Circle CI has to run those jobs. And Circle CI has a fair amount of privilege because it needs to be able to roll out all these things to the clusters. So you end up having to solve at your CI provider level, if you have a situation like this, the access to that provider. In the case of Circle CI, that means that you actually have to manage access at the GitHub layer because it inherits all its permissions from GitHub. So that's a bit more complicated. You end up having to lock down write access to a special set of branches from which deploys are permitted, and that gets fairly deep. But once you have all these in place, then you are secure from.
It's that easy.
It's really that easy. So these are a bit involved. We're going to go into a lot of this next time and dive into a lot of the nitty-gritty. So if you are interested in learning in particular about how to manage access to buckets and access to Kubernetes, that will be the big topics of our next webinar.
Awesome. Great, Joe. We'll look forward to the next one. I think we'll probably run it next week, the 11th. So be ready. And please subscribe.
Actually, it won't be next week, but
your content.
maybe the week after that.
Only week 18. Put it on your calendar. Awesome. Take care, everybody.
Thanks, guys. Bye.